Good morning, everyone. It's great to see so many people here for a talk that was just announced just a few minutes ago. Obviously, you're on a mission like us to bring the world forward from batch into stream processing. My name's Roger Barget. I'm the general manager for Kinesis. I'm here together with my colleague, Adi Krishnan, the product manager for Kinesis. Now, if you've heard in the keynotes, Andy and also Verinder today, we're actually broadening the family of Kinesis. The family now includes 3 services. So one of our objectives for today is to make sure that you leave the room understanding what each one of these services do and how they can be combined together to actually build even more powerful stream processing applications. But of course, the real focus for this session, oh, sorry, gentlemen. Okay, the visual aids do help. Okay, all right, we got the glitch passed. I'll say the real focus today, guys, is also Firehose. So after a little bit of introduction and talking about the services, we're going to dive deep on Firehose. Specifically, we want to make sure you understand the key concepts of Firehose, talk about what the experience is from S3 to Redshift, and because this is a simple and easy to use service, you'll actually find it's a very seamless and very easy to use experience. Talk about how you put data into it with the Kinesis agent, which is something new that we've just launched. We'll talk about that. And the key APIs, should you actually want to integrate, put data yourself directly into Firehose. Talk about pricing. Demo God's willing, we're going to run a demonstration for you and show it in action. And then deeper dive into the delivery patterns, understanding the key metrics, and how you actually troubleshoot your Firehose. All right. You know, there's a tenet for each one of the services that we're building that we adhere to. It's actually worth going through all of them. First and foremost, easy to provision and deploy and manage. With a few clicks from our console, we want you to get your service up and running. Elastically scalable. And these services are going to scale in different ways, and we'll talk about what scalability means for each one of these services. Real-time latency, because we're going to continue to squash latencies. And I talk about developments or advancements we've made in Kinesis. We've reduced the latencies there, but we want these services to be able to support real-time processing. And it's pay-as-you-go, no upfront costs. And when we get to the Firehose pricing, you'll find that you actually pay exactly for what you get out of the service, for exactly the data that you're putting into. And it's the last tenet that's really driven the development of these 2 new services, the right services for your specific use cases. We've been in market with Kinesis now for 2 years. We're learning a lot from our customers. We're hearing how they're using streaming, how they're using Kinesis, and we're identifying opportunities to actually jump in and actually build services that take that undifferentiated heavy lifting off our developers so they can actually start building more powerful applications on top of it. And it's that last tenet that has really motivated both Firehose and Kinesis Analytics. And I know some of you in the audience, this may be your first time hearing about Kinesis, you're new to streaming and you're here to learn. So let's go all the way back to the beginning. We announced and launched Kinesis, what we call Kinesis Streams now, at reInvent 2013. We're using it internally for our batching and our metering data. It was running at great scale. We brought it out as a customer-facing service. Let's just make sure we have a good mental model of how it actually gets used. We have the AWS SDK. Also just very simple put record API that allows you to put hundreds of thousands or millions or billions of events into Kinesis. You can, in fact, put a partition key into each record. When you create your stream, you can think about the I/O that you need to have, because each shard, which is a component of a stream, handles up to 1,000 transactions per second or 1 megabyte of ingress per second, and double that on the back end. So as a developer, you'd say, okay, what kind of data rates am I expecting? I'll go ahead and create my stream with the appropriate number of shards. And again, a tenet of scalability. As your business grows, you'd add more shards. But you might say, you know what, I actually want this, when I put this data in, I actually want to be able to associate specific processing with certain pieces of data. You can actually put a partition key in with each record. And a shard has a range of partition keys that it catches the data for it. So every time you write to that partition key range, it goes to the same shard. And also, we make it available in 3 availability zones before we allow you to read it, so the data is highly durable. And it's ridiculously inexpensive. A little over 1 penny for 1 billion put payload records, which is 25 kilobytes. And when we launched our payload, max payload was 50 kilobytes. And then on the back end, You basically have a 24-hour period of time in which you could process the data. We kept it durable for you for 24 hours. And the secret sauce to Kinesis is the Kinesis client library, that a developer building their application on EC2 could use the Kinesis client library build their application. The Kinesis client library allows you to get records from the stream, but it keeps track of exactly where each record processing application is at. If it fails, it can restart, pick right back up where it left off. And also because of auto-scaling, you can set an auto-scaling rule. You say, look, if we're falling behind or a big surge of data's come in, I want my backend to scale automatically. You could set an auto-scaling rule, and the KCL, because of the metadata it keeps in DynamoDB, would allow a new instance of your application to start, and together they would pick up and jointly tackle the stream. So this is what our infrastructure is. And we saw all sorts of customers building different back-end custom applications reading data off of the Kinesis stream. We've been in market now for 2 years. We have hundreds of customers worldwide who have deployed into production thousands of applications in ad tech, in gaming, and IoT, just to name a few. MediaMath, Bezo, Sushiro. These are all case studies that if you want to learn more, you can actually find on the AWS site and actually read how they've built their applications, how they've architected it. And in fact, if you just simply Google Kinesis, you'll actually find a number of articles that our customers have written themselves, just sharing best practices. Typical AWS fashion, we listen to our customers. 90% of what we have built is exactly what our customers have been talking to and asking for. So we have continued to invest in Kinesis Streams and will continue to do so going forward. And just look at what we've done over the last year. Some of our customers are saying, you know, an HTTP put call is kind of expensive for me. I'd really like to batch my records up and actually do a single call. We introduced a new API call called Put Records, which allows you to put up to 500 records or 5 megabyte per payload. And each one of those records could have the partition key, so the model is the same, just simple one big batch put. We increased the individual payload size from 50 kilobytes up to 1 megabyte. Our customers are saying, actually, we're using Kinesis not for these IoT, but we're actually doing some other interesting applications pushing larger data. So we increased the payload this year. We also significantly reduced the end-to-end latency, specifically from the time Kinesis caught it to the time you could actually process it is way down in double-digit milliseconds now. Significant reduction, and we're going to continue to push that down. We introduced the Kinesis client library because some of our developers are saying, hey, we're a Python shop, we're a Node, we're a Ruby shop, and we're going to continue to do that as well. We want to meet the developer where they are today. We also introduced the Kinesis Producer library. This is a library that you can embed into your code. It implements best practices for putting data into Kinesis. It provides metrics so you can track exactly how your producer is doing and monitor how the Kinesis producer is doing. Again, trying to make it even simpler to put data into your streaming data into Kinesis. And last month, we introduced server-side timestamp. So as your data arrives into Kinesis, we put a timestamp because you may actually want to do something, a reason about the time. So if you're unable to put time in yourself, we're putting a timestamp on it for you. We're also pleased to announce today, Werner mentioned his keynote, I just want to make sure we hit it, announcing extended stream retention. We're going now beyond 24 hours to a full 7-day retention period. And 3 days before this event, we were going to launch it, we actually had a customer call us frantically, and they said, we didn't realize our processing application's been down, and we're 22 hours behind, and we're afraid we're going to lose our data. And so we turned it on for them, and they successfully have now actually used the feature to catch up with their data. It's working! So, thank you. So the team has been really busy on Kinesis Streams. But we kept seeing, and yeah, here's how I want to summarize this, guys. When you need that record by record processing to build a custom application, you want to have control over exactly the capacity that you provision. This is what Kinesis Streams is for. And it's not just the KCL. We have Apache Spark Storm that you can actually process your data with, AWS Lambda. It's only limited by your creativity. And we're going to continue to actually innovate on this so that you can build your custom streaming applications using Kinesis Streams. In fact, we're going home with a great list of ideas, and we hope to even get more feedback from you while you're here. But we also started to notice this pattern. It was, in fact, this time last year, talking to customers at reInvent. And I'll just put Sushiro. I love this application because they're really bringing the latency down by monitoring their customers and how they're eating sushi. They have these RFID devices on the bottom of each plate. You pick that plate up. They know what was on it. They know how long it was on the carousel. And they, back at headquarters, can see demand across all 340 or 380 stores and place an order for tuna and have it shipped to the store because they realize it's selling like hotcakes. Good real-time business processing using Kinesis. But if you double-click and look at their architecture, here we go. Basically, they're feeding it in Amazon Kinesis. They have an application that they had to write. They put it into Redshift, and Tableau is their user experience. And if we think back about DataZoo, DataZoo was actually dumping all of their data. Did we move the DataZoo example? Sorry, guys, I think those slides got lost. DataZoo is another example that we're looking at. And then their golden rule is to dump all data into S3, going in and out of the business. Almost all of our customers, Kinesis customers, are putting data into S3. It is the archive for their business. If they're doing analytics, they're also putting it into Redshift as well. We said, wait a second, that takes time to actually, they have to write an app. They have to write an app, they have to provision the resources to actually do this loading. And how many customers might actually start getting excited about streaming if they didn't even have to write an app? This is exactly what motivated Amazon Kinesis Firehose. There's absolutely zero administration required. Today, we'll move your data into S3, into Redshift. Soon it will be to every destination that our customers care about. But you don't have to write an app. You don't have to spin up any EC2 instances. It just works. Okay? In addition, just the high points here, you can batch it before we send it. You can compress the data with the gzip, zip, and snappy. You can encrypt it with KMS. And in as little as 30 seconds, we'll pick that data up and move it into S3 and into Redshift. And we'll talk more about the details in the talk today. And seamless elasticity. This is a big one. And that we're prepared to take whatever data that you throw at us. The moment you create a Firehose, we're provisioned to handle the 98th, 97th percentile of customers that we see today. If you're one of those top 1 or 2%ers, let us know and we'll even provision more for your Firehose. But basically, we will automatically scale. You do not have to worry about getting throttled if you're under those limits. You do not have to worry about managing partitions or anything. It's just ready to go. Just throw the data at us. So the customer experience, just to talk a little bit about that. There are only 3 simple concepts that you have to be aware of. You create a delivery stream. A delivery stream is associated with the destination. And it's this delivery stream, which is actually the underlying unit, which is actually moving data. You don't have to create or provision shards. You don't have to specify partition keys. You simply do a create delivery stream. There's a notion of records. These are the things that are being transmitted across to your delivery stream. Up to 1 megabyte payload per record that gets transmitted. Third, data producers, and we'll talk about that in a second, but they're the things that actually send the data into the delivery stream, so it will then appear into S3. That's it. 3 very simple concepts you have to understand. And later when you see the API calls, you'll see how it maps to these concepts. So today you can find Kinesis under the single Kinesis console. Right now I see 2 options, Kinesis Streams, Kinesis Firehose. When Kinesis Analytics is available, it too will be under the family on the console. You simply say, I'm going to create a Firehose. First thing you're asked, you're really configuring the delivery stream. What's your destination? You specify Amazon S3. You name your stream, because we assume you're going to have lots of these as you move your streaming data into AWS. You tell us what bucket it's going to appear in, what's the prefix, and your IAM role. Next thing that you do, what's the buffer size that you want to have delivered before you actually flush and actually push it in? And what's the buffer interval? Anywhere from 60 seconds up to 900 seconds. If either of those 2 thresholds are crossed, the data's flushed. This is real continuous delivery of streaming data. You'll see we have an agent I'll talk about in a second, but literally you're going to point at the files where this data, the log files where this data is being created. You could have it running up every 60 seconds. Or you could say, look, when I get 2 gigabytes, when I get a few megabytes, I want it uploaded. You specify what method you wish to use for compression, and if you in fact wish to encrypt it, what KMS keys you'd like to use. That's it. What about the Redshift experience? A little bit different, slightly. First and foremost, we use a customer-provided S3 bucket as an intermediate destination. This is still the most efficient way to do large-scale loads up to Redshift. Not only that, there's absolutely no way we can lose the data. Should Redshift be unavailable, should you be getting throttled or have some other issue because one of your developers are working on Redshift or doing something, your data is going to be safely put into S3. And yes, we will try to repeat if we encounter errors when you talk more in the deep dive about how often we do that. Not only that, some of our customers are saying, actually, we actually want to do processing on S3 with EMR, so having it in S3 is actually kind of a bonus. And what we'll do, Firehose will issue your customer-provided copy command synchronously, and it will continuously issue a copy command once the previous copy command is finished and acknowledged back from the Redshift. So again, data's coming into S3, into buckets. Basically, we're issuing your copy command right in parallel, one right after the other, until we get your data into Redshift. Only thing to point out on this experience, and I realize in the back of the room this may be a little small, but guys, all you have to do, and it's actually also worth noting on the service, you specify your Redshift cluster, your Redshift database, your Redshift table. The previous information on the top is your S3 bucket, your username, your password, and your copy command, which you can test and see how it actually works. Now, at present, a limitation is that a Firehose or a delivery stream is associated with one Redshift cluster, one database, and one table. So for those of you who are actually streaming your data to multiple clusters or to multiple databases, Firehoses are free to create only when you use them, so you can actually create multiple Firehoses. Over time, we'll actually see about actually coalescing that so you can actually have a single Firehose putting to multiple databases and multiple tables, but this is how we start. All right, we're also introducing the Amazon Kinesis agent. This is an agent that you can download, install. It will monitor the files that you're saying here. You tell it, these are where my log files are being created at. It monitors and sends new records to your delivery stream, either based on time or amount of data in that file. It handles file rotations, checkpointing, and it does retry upon failures. Again, it's implementing best practices for putting data into Kinesis. It'll do retries and handle all the corner cases for you. And it delivers data in a reliable, timely, and simple manner. It also emits AWS CloudWatch metrics to help you better monitor, troubleshoot the streaming process. And Audie's going to go into the kind of things, issues that can happen, and basically what the metrics would be telling you. And it's supported today on Amazon Linux AMI version 2015.9 or later, Red Hat Enterprise Linux version 7. And again, the idea is you install this on your Linux environment, such as web servers, front-end, or log servers. And it's also enabled for Kinesis Streams. So for those of you who are using Kinesis today and would actually like to have an agent that would automatically start pumping data into your Kinesis streams, please, by all means, start using that and give us feedback on it. Okay. Now, maybe you don't want to use the agent. Maybe you've got some code written that you'd actually just simply like to embed Firehose into your existing application. Here you see the API for Firehose. And the first four, they're parallels with Kinesis. Create stream, create delivery stream, create delete stream. Well, we have a delete delivery stream, list delivery streams, update the destinations for a delivery stream, and then finally put record and put batch record into your delivery stream. Very simple API if you actually want to roll your own, like some of our Kinesis customers have done with the Kinesis API. The price? 3.5 cents per gigabyte ingested. And I didn't say delivered, ingested, because that's the same price if you go to S3 or to Redshift or to both. Okay? So hopefully that price point actually tickles you, that it's actually a relatively low price point. So at this point, just to stop before we do a deeper dive, say, okay, when would I actually use Kinesis Streams? When would I use Firehose? It's real simple. I mean, if you want to do a record-by-record processing with custom logic to feed your own dashboards, to do your own custom processing, you want to use Kinesis Streams. You get sub-second latency on that processing. You get your choice of stream processing frameworks that you can support on an EC2 instance. You have complete artistic control as a developer to actually build your own stream processing applications. We'll continue to see developers using that. Firehose, maybe you're finding value out of Redshift S3. Your apps are already reading and working on those today. You can now immediately, with a no hands-on approach, start delivering your data through Firehose within seconds, within a minute or more, up to Redshift and to S3. No application to write, nothing to manage, don't have to worry about the heat, don't have to worry about capacity management. It will take care of it for you. So with that, I'm going to turn it over to Audie. He's going to take you down for a deeper dive.
Thank you, Roger.
Yep.
Hello, everybody. Thank you so much for joining us this morning. I know it was an embargo session, so it jumps in late. So hopefully you have a good idea for what Kinesis Firehose is, kind of the genesis and why we built the service, and you know how to kind of compare, contrast it, if you will, with Kinesis Streams. Let's look at some specifics about the delivery mechanism into S3 first. And before we jump in there, how many of you use S3 today? Show of hands. Yeah, I would have been shocked if it was lesser than that. How many of you use Redshift for any sort of analytics? Neat. How many of you have some other system, some analytical system that relies on S3 for its kind of durable persistence? Right. Great. Thank you. So let's look into details of what it means to deliver data into S3. So as Roger mentioned, one delivery stream loads data into one of your buckets. The buffer size and intervals, as Roger mentioned, are what ultimately control the size and frequency at which the data, more specifically, the S3 object is created and put into. The dimensions range from 1 megabyte to 128 megabytes on the size of the resulting buffered file, or from 1 minute to up to 15 minutes. And the buffer operation is effectively a concatenation operation. So as you put data using either the put APIs or perhaps using the agent or any of the AWS SDKs, each record, if you will, is getting concatenated with the one that follows until your buffer condition evaluates to true. Either one of those conditions can satisfy, the first one that satisfies the condition triggers the actual put to S3. So from a pricing perspective, think of the puts into S3 and the S3 storage as distinct from the core Firehose costs, in case there were some of you who had perhaps had that confusion. The compression operation for Firehose is optional. There are 3 algorithms that we support today: gzip, zip, and snappy. Some of you are probably thinking about LZO, which is a compression that Redshift really likes. As you can imagine, it's something that we'd like to deliver fairly soon. And as you can imagine, since the compression is happening after the buffer operation itself, the actual size of the S3 object could be smaller than the amount of data you've actually put, the raw data you've put into Firehose. Kind of obvious, but to prevent you from surprising yourself. And for Amazon Redshift, you'll notice that the only compression option that's supported right now is gzip. Okay, so the next step. Firehose, because it's delivering data on your behalf, you need to grant it permissions via IAM roles. The Firehose underlying entity, which is the delivery stream that is created, will assume the specific role to gain access to your target S3 bucket. There are default delivery roles in the experience, but you can write your own, craft your own specific delivery role. And then we can go into depths later on what exactly are the minimal set of permissions you need to provide for Firehose to successfully put data into your S3 bucket. Firehose also enables encryption via the AWS Key Management Service. So how many of you here use KMS, or the Key Management Service? Great. KMS is a newer service that we announced, I believe, last year, or earlier this year maybe. And it's a fully managed service that makes it easy to create and control the encryption keys that are used for encryption on a variety of different services. So on the S3 front, what Firehose does is that you give it access. More specifically, Firehose will pass the KMS ID that you've already created for your S3 bucket, and then uses the encryption context that S3 already has, typically using the bucket name and the object name to encrypt your data. So this is still the S3 KMS encryption integration that Firehose is able to rely on. So just to be clear, if you're already using KMS, you should not see any difference in how this operates. Just like for your S3 bucket, Firehose needs to be given permission to access the specific key, the KMS ID needed for driving through the S3 encryption. Again, the encryption is optional. So if in your use case that makes sense, you can go ahead and use it. Let's now talk about what does it mean, what does the object look like as it gets delivered into the S3 bucket. And this is going to be interesting because you're going to have a bunch of downstream flows that rely on the pattern or the naming convention of the file itself to drive your downstream workflow. This could be running a classical MapReduce job. This could be running a Presto, Hive, Impala query. This could be running your own custom application. This could be triggering a Lambda function as soon as Firehose completes the S3 put successfully. whatever the downstream service or application is that is picking up the data from S3, it's good to have a sense for how is the data going to be laid out inside of your S3 bucket. So Firehose adds a UTC time in the format that's shown on the screen before putting objects into the bucket. And as you all know, the prefix effectively translates this into a folder structure of sorts, where each label separated by the / becomes a bit of a subfolder. Now, you can modify this mechanism, or at least add to it, by also optionally specifying a prefix, so which effectively becomes your own top-level folder. If you add a / to it, then it becomes in the form, my app / followed by the existing prefix, or you can do so just as a prepend, something that's truly prefixed to the existing convention without having a folder structure, if you will, associated with it. And expect the delivery pattern to be of the kind noted. It's a pretty long one, so I'm not going to read it. The random string towards the very end is a GUID that Firehose generates. And the one thing to note here is that the delivery stream version will get updated each time you make a configuration change into your Firehose. So maybe you went from, instead of buffering from 5 megabytes, maybe you went to 50 megabytes, or maybe you dialed down from a 15-minute interval down to a 5-minute interval. So those are all examples of config changes. Those config changes result in a new underlying delivery stream version update. It is still your same delivery stream. Nothing changes in the way you put data, and nothing changes in the way the data is being delivered in a timely fashion, because Firehose will update those configurations on your behalf. You'll just see the data appear, let's say, later if you dialed up the buffer interval, or you might see the data become smaller as you have, let's say, included compression. But the key thing is that the naming pattern will be updated to take into account the new delivery stream version number. The reason I'm flagging this for you up front is that if your analytical consumption process relies on that stream name, you want to make sure that it can account for this variance. So as you can imagine, one of the core things right off of that is, well, you are relying on Firehose to do its job of delivery into S3 in a zero-touch, complete peace of mind manner. But given this is a fully managed service that is interfacing with another fully managed service, there could be a case where your S3 bucket cannot be reached by Firehose. And there are a variety of good, reasonable conditions under which this can happen. But if it does happen, the Firehose behavior is as follows. It'll try to access the S3 bucket every 5 seconds until the issue is resolved. So it's going to effectively try to put that data. And it needs to do that because you're continuing to slam data into Firehose. Firehose is continuing to buffer up objects, if you will, as it's trying to then lam the data into your S3 bucket. Let's say that the S3 bucket isn't available for hours, for whatever other good reason. Firehose will continue executing the way it's supposed to and buffer up all data for 24 hours. This is where the shared ancestry of Kinesis Firehose and Kinesis Streams really comes into play. And so, rest assured, all your data is saved for 24 hours until the situation itself is resolved, at which point Firehose will resume delivery per your desired configuration. So if it's set, 5 MB buffer size, you will notice that the configuration conditions are not violated. You still get 5 MB objects per the naming configuration, and Firehose will try to catch up as quickly as it can as soon as the bucket comes back up. And of course, kind of the caveat here is that it is a 24-hour window. So there is a shared responsibility in making sure that the S3 bucket does indeed come back online and is accessible for Firehose. So the core Firehose to S3 mechanism is relatively simple. And let's switch gears a little bit and talk about Firehose to Redshift. So as Roger mentioned, this mechanism is a two-step process, still uses your S3 bucket as an intermediate staging area before Firehose issues the Redshift copy command, which several of you are familiar with if you use a Redshift. Loading data from S3 into Redshift remains one of the most popular ways and arguably some of the most efficient ways to do large-scale data loads into Redshift. And that's the procedure. So Firehose isn't, at least yet, doing some direct writing into your Redshift nodes, if you will. So let's discuss now what it means what is the timeliness around data delivery into Redshift. So the first step is, since the data is landing inside of S3, whatever specific buffer size or interval that you've set will first apply. So let's say you've set a 1 minute interval. So data that's put into Firehose will take a minute until it shows up in your S3 bucket, and then it'll do so continuously on a minute-by-minute basis. The next thing that the Firehose accomplishes on your behalf is running the Redshift copy command. The mechanism for the Redshift copy command is one of Firehose continuously, synchronously executing the copy command, waiting for the cluster to come back with a positive ACK, and then uploading the next file into it. And for efficiency, actually, Firehose does a manifest copy. So as the files are being generated, it's maintaining a manifest of each file that needs to be written, and then executes a manifest copy inside of Redshift. So let's dig a little deeper on the Redshift copy command mechanics as Firehose uses it. So the governing principle for Firehose is really one around recency, so get the latest data in quickly. And the second governing principle is one of zero error tolerance. So if a single record within the file fails to load, the whole batch of files in that manifest, and therefore the entire copy command, will fail. So that is the Firehose model, which is one of the two models that the Redshift actually offers to customers. You can set either conditions on how many files you're allowed to fail inside of the Redshift copy command, or you can choose to fail the entire batch. The model that Firehose aligns with is the second one, so it chooses to fail the entire batch. All the objects that were skipped as a result of this are delivered into the same S3 bucket under an errors folder. So the objects, the manifest, are both, if they were skipped and the copy command did not succeed, are simply placed into the errors folder inside of your S3 bucket that is the intermediate staging area. So a natural kind of question is, well, okay, so what if now my Redshift cluster is not accessible for any good reason? Now, on the good news side, the data is still available in S3. So the data is still over there. But the Firehose mechanism around dealing with lack of access to your Redshift cluster is as follows. If the cluster is not accessible, it'll retry every 5 minutes up to a 60-minute window. And if the cluster is still not reachable for a period of 60 minutes, it'll skip the current batch of objects that it was meaning to write and move on to the next one. And like before, those skipped objects, along with the manifest, is placed in the errors folder. Now, again, on the good news side, you have access to that data. But I guess on the not so good news side, there is a somewhat more potentially complex backfilling procedure that you will have to run to reintegrate the missing data, if you will, inside of your Redshift cluster, more specifically, the table inside of your Redshift database. Now, we realize that part of making things super simple is also making sure that the set of metrics and monitoring mechanisms that we ship with give you a pretty good, clear, transparent idea of what is going on in the system. And we frequently hear this from customers. At least tell me if it was you or was it me, right? And that's kind of, we want to make sure that we can, at the very minimum, go there and then do a little bit more. All the APIs that are ultimately being used have a core set of metrics, as usual, that are available inside the Firehose console and inside of CloudWatch. Where I'm going to focus is on the specific service level, if you will, metrics that make identification of some of the key problems easy. So let's have a look at the metrics really quickly. Some of them should be pretty obvious. So incoming bytes and incoming records, regardless of what put API has been used to get the data in, we capture counts of both of those metrics. From an S3 perspective, we also have delivery to S3 bytes and delivery to S3 records. Again, that makes sense. And it's exactly what the metric indicates in its name. Delivery to S3 data freshness is kind of an interesting one. Its goal in life is to tell you the age of the oldest record inside of Firehose. So when you look at that metric, which will be in seconds, you can say, hey, Firehose has been delivering the oldest data that was delivered is 30 seconds old, or 1 minute old, or 90 seconds old. And any data older than that is guaranteed to have already been transferred into your S3 bucket. So this is a good way to say, hey, am I slowing down? Is the system slowing down? Is there data that I should be seeing, but I'm currently not seeing? So the data freshness metric will help you get a good idea of what that is. And then lastly, because Firehose is executing a put call into your S3 bucket, that's how the actual data delivery part is happening. We have a simple success metric, which is a ratio of successful puts above all S3 put commands that's been executed. So whenever that ratio starts trending if it's not trending towards 1, then we know that there have been some failures. Similarly, for Redshift, there are 3 analogous metrics. So delivery bytes, records, and a success metric. The success metric, just like for puts, is actually Redshift copy commands. So successful Redshift copy commands over all copy commands that were executed by Firehose on your behalf. Okay, so now let's look at some key questions that you might have to confront with during a troubleshooting scenario. The first one, and this is regardless of a troubleshooting thing, this could just be an operational best practices, is my data flowing end to end, right? So whatever I've put into my Firehose from any number of different, or any diversity of different data producers, is it actually showing up in S3? And for this, the metrics that we reviewed, specifically incoming bytes and incoming records, along with delivery to S3 success or delivery to Redshift success, so the data is landing inside of Redshift, can be used to confirm at a glance what I put in, is it actually flowing through and landing inside of the destination, S3, Redshift, or both. And of course, because all the core API level metrics are also available, for those of you who are more inclined to look at that, can access that as well to kind of verify and cross-check. Okay, so what if the key question is, how much data is being captured and delivered to the destination? So here too, you can look at the put records bytes, put records, the bytes, and the request, regardless of which API you're using, the put record or the put record batch. That would be the data volume that is captured by Firehose. And then you can check the delivery to S3 bytes and records, or delivery to Redshift bytes and records, to know that, okay, what was being captured, is it really being delivered? Of course, you'll have to bear in mind here that in case you are choosing one of the compression options, that what you deliver will be smaller than what you've put inside of the Firehose. So don't freak out. And you can obviously also verify all incoming records and incoming bytes again to see that, and get a check for, is data really flowing, what is being captured, and what is being delivered. The next question that you might want to ask is data being delivered in a timely manner? And over here, again, the data freshness metric will be useful. Because it shows the maximum age in seconds of the oldest undelivered record, you know that anything later than that has been delivered. Anything after that is still being buffered or processed by Firehose. This one can happen fairly frequently, potentially. This one is around, well, what is going wrong? Is it with Firehose? Is it with my bucket? Or is it with my cluster? And you want to always start with the success metric, the S3 or the Redshift version of the delivery success metric to at a very minimum get, okay, assuming that the data is indeed being captured, is it actually being loaded? And if, let's say, in a scenario where the S3 success metric is trending below 1, then it suggests that there is a potential issue that Firehose is having in putting data into your S3 bucket. And similarly, for Redshift. So what are some of the key steps that you might take if the data is not showing up in S3? So you might want to do something like, firstly, you check the incoming bytes and records. Okay, is my data being put successfully? The second thing you might do is check the success metric, as we discussed, to make sure data is actually being put. You want to ensure that the S3 bucket that you specified in the delivery stream configuration is indeed that something hasn't changed about the S3 bucket, or it hasn't been taken offline, or it hasn't been, it's not currently being used in some other manner that you did not know someplace else. And you want to always make sure that the IAM role and the permissions that associate with it, that Firehose is assumed to do puts, have not been changed such that Firehose is now not permitted to put data into your S3 bucket. Somewhat analogously, there are some key steps you can take when data isn't loading inside of Redshift. Now, because Firehose is loading data today only in a single Redshift cluster, single database within that cluster, and a single table within that database, it operates in a pretty straightforward manner. Now, having said that, though, like before, you want to check your incoming bytes and incoming records. Data's coming in. You want to check your S3, make sure that the data is in fact being staged inside of S3, that you can do with the S3 success metrics. And similarly, on the Redshift success metrics, when either of those are trending under 1, there's a problem there. Next, you can check the Redshift's load errors table to verify the actual reason of the copy failure. Now, for those of you who are using Redshift, probably know this already. And you want to make sure that all the configurations that you've specified inside of Firehose, available both within the console and via the API, the configurations are accurate, including, as before, the IAM roles themselves. So I'm going to switch a little bit and give you just a flavor for what was announced today about Amazon Kinesis Analytics. And before we go there, Firehose is available for all customers. It's available in our US East, US West 2, and our EU West regions. And it's open for all customers to use at scale. Amazon Kinesis Analytics was announced today. It is not currently available for you to try out. It will be so shortly. But I do want to give you a flavor for the 3 things that we're targeting with analytics. Now, as you can imagine, given what we shared at the keynote, the key thing is stream processing has been out of reach for many, many customers. And it's beyond merely managing infrastructure. The fundamental thing that we've learned from customers is that it's a new programming model. It's a new distributed programming model that imposes a very steep ramp. What we've heard, and there will always be a place for the right tool for the right job, something we strongly believe in. And a variety of stream processing frameworks exist, will continue to exist, and new ones will come up. But the one that came back to us time and time again was the ability to express SQL directly over streaming data. As you can imagine, SQL is available, broadly known by large sets of developers with or without distributed system skills. And what Kinesis Analytics will do is enable you to connect in to Amazon Kinesis Streams and Amazon Kinesis Firehose as at least 2 streaming data sources. We make the task of connecting extremely easy. You can parse and schematize the data, and you get the ability to apply templated functions, SQL functions, onto that data stream directly. Because this is still a stream processing engine, we do care about latency. We will continue to target sub-1 second processing latencies, possibly end-to-end. And lastly, because a lot of the underlying distributed systems coordination, including scaling, including doing things like item potency or exactly one semantics that today, if you want to get to that, it is an incredible amount of work, is things that we will execute underneath the covers as a best practice. You do none of that, and we will enable elastic scaling of the engine as well. So imagine putting data into your Kinesis stream. You have complete control over how the Kinesis stream scales. In response, you've got your Kinesis Analytics infrastructure that will scale as your incoming stream scales in size. I know a lot of you are probably excited about Kinesis Analytics. It's an announcement only. Happy to take questions after we're done. But Firehose is available today, Kinesis Analytics soon. So just want to round things up here and talk to you about the Amazon Kinesis family. As Roger mentioned, 2 years ago at this very venue, we started on that journey, and the family has grown. Amazon Kinesis is now a family of streaming data services that help you capture, deliver, and process real-time data streams on AWS. Amazon Kinesis Streams is where it all started, targeted towards developers for complete control over how you partition the data, how you scale the stream, and then complete control over building your custom stream processing applications using any framework or tool of choice. Amazon Kinesis Firehose, as hopefully you learned a little bit today, gives you a fully managed zero-touch mechanism to capture and deliver data into destinations like S3 and Redshift. And in the future, Amazon Kinesis Analytics will enable you to apply SQL queries directly to the streaming data sources, namely Kinesis Streams and Firehose. So hopefully that gave you a good flavor of Amazon Kinesis Firehose, and hopefully you can all get started really quickly. I'll take questions for the next 10 minutes or so. Thank you.